Right now, in fields and food silos all over the world, there's a silent, microscopic war being fought. And what's at stake? Well, it's the safety of our food supply.
Yeah, it sounds like something straight out of a thriller, but this is a very real and growing threat. We're talking about an invisible, naturally occurring poison that can find its way into everything from your morning cornflakes to your favorite peanut puddle.
So let's meet the villain of our story. It's called aflatoxin. This stuff is produced by a super common mold, and it's considered one of the most potent mycotoxins on the planet. And when I say potent, I mean it's a known carcinogen. Really nasty stuff.
And the thing is, this threat is everywhere. It loves to grow on major crops like corn, nuts, and spices. It doesn't just cause cancer, either. It can actually damage our DNA and suppress our immune systems. What's worse, a warming climate means this kind of contamination is probably going to get more common. That's why food safety agencies are so incredibly strict. To give you some perspective, the EU sets the limit as low as 2 micrograms per kilogram. That is like trying to find 2 specific grains of sand in an entire ton. It's that serious.
Okay, but where there's a villain, you can usually find a hero. And in this story, our hero is just as tiny, and it comes from a place you might not expect, the dirt right under our feet.
So let me introduce you to Streptomyces. You've probably never heard of it, but this ordinary soil bacterium is a total powerhouse of biochemistry. And now scientists are figuring out how to use its natural talents to fight back against aflatoxin.
See, Streptomyces is already a superstar in the medical world. It's a natural factory for many of our antibiotics. But it also produces these powerful enzymes that can literally dissolve the cell walls of fungi. This makes it the perfect candidate for a natural, safe, and cheap way to protect our food.
So how do we actually know this tiny defender can win the fight? Well, scientists decided to find out by staging a microscopic showdown in the lab.
They use 2 main approaches. The first one is called a dual culture assay. You can basically think of it as a microscopic cage match. They stick the bacteria and the fungus on the same plate and just see what happens. The second method uses something called cell-free extracts. This is less of a physical fight and more of a test of the bacteria's chemical weapons, all the enzymes and compounds it releases.
And the results from that cage match? Whoa, they were absolutely staggering. Left on its own, the fungus just grew like crazy. But when it was put face-to-face with Streptomyces, its growth was slashed down to just 13%. The bacteria physically stopped that mold dead in its tracks.
But here's where it gets really mind-blowing. The bacteria didn't just stop the fungus from spreading. It stopped it from making its poison. The aflatoxin levels just plummeted to less than 1%. That is a near total shutdown of the toxin factory. Incredible.
Okay, so that brings up a really important question, right? It's fantastic at preventing the poison from being made in the first place, but what if a crop is already contaminated? Can our little bacterial hero actually clean up a mess that's already been made?
The answer to that question is a process called biodegradation. This is basically nature's cleanup crew in action. It's the amazing ability of a microbe like Streptomyces to grab a dangerous chemical and just dismantle it piece by piece, breaking it down into safer, harmless parts.
And the tests show that it absolutely works. Scientists measured what they call the genotoxicity of the aflatoxin. That's its ability to wreck our DNA. Well, after Streptomyces got to work, that toxicity was reduced by as much as 68%. So this isn't just about hiding the poison, it's about actually disarming it.
So, let's recap. We know it stops growth, we know it blocks new toxins, and we know it cleans up existing ones. But how? How does it pull off that almost total shutdown of toxin production? Well, the answer is even more clever than you might think.
It all comes down to what's happening at the genetic level.
It's nothing short of genetic sabotage. See, Streptomyces doesn't just fight the fungus on the surface, it wages war on its fundamental programming.
Research published in the journal Microbiology found the smoking gun. It turns out Streptomyces specifically targets and shuts down a key gene in the fungus called AFLM. Think of this gene as the master switch on the aflatoxin assembly line. By flipping that one switch to off, the bacteria basically grinds the entire poison factory to a halt.
So let's pull all this together. What we're really looking at here is a completely natural, multi-layered strategy for making our food supply safer for everyone.
It's this beautiful 3-part attack. First, you've got growth inhibition.
It puts up a physical wall. Second, it performs toxin degradation, actually cleaning up any contamination that's already there. And third, it uses gene repression to make sure no new toxins can even be made. It's an incredibly smart and comprehensive defense system.
And you know, this is bigger than just one bacteria fighting one fungus. This research proves a powerful concept. It could open the door to a whole new way of thinking about food safety, where we use natural enzymes and compounds to detoxify our food instead of relying on harsh chemicals.
Which really leaves us with a pretty cool final thought. For so long, we've looked to sterile labs and big factories for the answers to food safety. But maybe, just maybe, the most powerful solutions have been right there under our feet the whole time, just waiting in the soil for us to finally pay attention.